Okay, we've just been seeing tan. So we've only been doing this last one, tangent, which is opposite and adjacent. Now the other two are exactly the same. So what I really hate to see, and there's always a few people who kind of like, they just like get really attached to tangent. Like they're like, we did tangent for 3 days, and I love it. Like it's so great. It works all the time, okay? And I just want to keep using it. And that's fine. Like technically, I mean, it's not fine. It's not ideal at all. Technically, you could get through all the problems just using tangent. You could. But it will take like twice as long. Okay, so there's no point in doing that. It's actually harder. Okay, so even though you're avoiding, like right now it feels easier because you know tangent already, it ends up being harder because it's much faster to just use the appropriate ratio in the right situation. Okay, so every situation is different, and today that's what we're going to be looking at. We're going to be looking at what happens when tangent isn't the right ratio to use. And you've even seen problems like that. Like I've had you do problems where tangent wasn't the right ratio to use, and that's the situations where you like have to use the Pythagorean theorem to get a missing side, because you don't have the opposite, so you need to do Pythagorean theorem to get it. That's a situation where tangent isn't ideal. It would be much faster to just use either sine or cosine. So sine, okay, remember we talked about SOHCAHTOA. TOA. We're getting to the point where you're really going to have to use that, because up until now you just kind of knew it was going to be tan. You knew it was going to be opposite over adjacent. You didn't have to think about that. But now we're going to have to be thinking about that every question. Which should we use? Should we use sine? Should we use cosine? Or should we use tangent? Okay, so sine, on your calculator it's SIN. It's like a pet peeve of mine when people call it sin, so please don't. It's sine. And then COS is cosine. That one people sometimes call cos, and that bothers me less. But sine A, cosine A. The rule for it, just like tangent, so that A there is kind of standing for angle, right? We're taking the sine of an angle. And remember, ratios, I talked about the first day that we learned this stuff, is just a comparison between two numbers. So tangent, I'm comparing opposite and adjacent to one another. That's what the ratio is. I'm taking opposite and adjacent, I'm comparing them. For sine, it's just opposite and hypotenuse instead of opposite and adjacent. That's it. Just a different side. You just don't put A on the bottom, you put H on the bottom. Okay, for cosine, same thing, except it's again different. It's cos, so it's adjacent over hypotenuse on the bottom. So all the time you're going to have two sides, right? And depending on which two sides you have, that will determine which one of these things you use. If you have a question where you're given the opposite and the adjacent, use tangent, because that's the one that has opposite and adjacent. If you are in a situation where you're given opposite and hypotenuse, you'd use sine, because that's the one that has opposite and hypotenuse. So let's look at an example. Once you see an example, it kind of makes it a little bit easier. Okay, so here, DEF, this triangle here, identify the side opposite and adjacent to D, angle D. So that's what they're asking us for. So if I'm looking at angle D, this is pretty easy. A, right? Ooh. Okay, that angle there. Opposite and adjacent to that, 5 is opposite, 13 is hypotenuse, and 12 is adjacent then. Okay, I tricked you a little bit.
But all students involved in this morning's liturgy, please make your way
There we
to
go.
the gym.
Rihanna, she's a hero. She's going to be involved.
Participating in the liturgy,
Okay? Well, I'll look for her during the liturgy. Okay. Okay, so we have our opposite, our adjacent, and our hypotenuse. Now, when we're trying to figure out here, it asks us for sine of D and cosine of D. Here, that's what it's asking us for in question B. What you're going to do is just write down that ratio. So this is the part, like we're going to have a progress test, a little quiz on Tuesday. Okay, I'll remind you Monday on all this stuff. Now, these questions where they just ask for sine or cosine or tangent are the ones that students always get wrong. Because what I always end up getting is the angle. Students will give me the angle. Remember that if it asks for sine, it just wants the ratio. And so that ratio, it can be a fraction or it can be a decimal. But it can't be the angle. Like if you get 42, that's wrong. Okay, that you created the angle there. You found the angle. So instead, Okay, what we're going to do here is sine D. Okay, sine D, okay, is 5 over 13. It's that easy. Okay, 5 over 13. Okay, because it's opposite, which is 5, over hypotenuse, which is 13. And the way that Winston knew that is because he knows SOHCAHTOA. Okay, so it's SOHCAHTOA. So it's opposite over hypotenuse. Okay, so if you just write that up at the top of your stuff, right, like it's O and then H for sine. Now, this question in particular, it says, determine sine D and cosine D to the nearest hundredth. Okay, so it tells us how it wants the answer to be written. So here, 5 over 13 is not an acceptable answer because that's a fraction. It's not to the nearest hundredth. I would have to type that in, but I don't type in second sine 5 over 13. I just type in 5 over 13, and I get, what do I get? 0.384, so to the nearest hundredth would just be 0.38. Okay, so a lot of you, and I actually like that a lot of you have been keeping them fractions. I think keeping them fractions is awesome. But in a question, if it says that you have to round it to the nearest hundredth, you have to type it in and do that. Okay, otherwise you're going to lose. Yeah. Yeah, so in this situation it said hundredth. And it could say even more than that, right? It could say the thousandth or the, I don't know, it could tell you to 4 decimal places or 5 decimal places. It could do anything it wanted to, really. But just make sure you're reading how it wants it rounded. So that's sine of D. Cosine D, really similar. Yeah, so it's ka, right? That's, ooh, I'll do it in red so we can actually read it. Ka. Okay, so I guess we can't really read it anyway because it's a little bright. But ka, adjacent, and hypotenuse. Okay. So it's 12 over 13. Okay, and then I type that in here. 92. So it's 0.92. You'll notice these numbers, cosine and sine, are always going to be little decimals underneath, like under 1. Like they're always going to be like 0.4 or 0.5, 0.6. They're never going to be higher than 1. So that's how...
Why'd you use 12?
Because that was, so SOHCAHTOA, so it's AH, so it's A over H. Yeah, that's a good question though. It's like, it's tricky at first. Okay, so for you guys right now, what I'd like for you to do is start this question fresh, okay, and just like it says down here, find sine F and cosine F. So instead of looking at D, which we were just looking at, I want you guys to look at F. Okay, so and how's that going to change things? That's right. Okay, we're going to have to switch some of the numbers around. Okay, so see if you can find cosine F and sine F. Then I'll do it so that you can make sure you're correct. Missing some people today. Thanks anyway. 5, 6, 7, 12. 5, 48. We are missing a few. Okay, so this is when trig is getting a little more like we're really doing it now. We're using all 3. Before that, it was just sort of practice. That's a little too dark, but it does make the board nicer. Just look, it's scary though. I don't want to be all dark. And make sure you get it as a decimal, just like I got it as a decimal. I find like sometimes students don't know how to get these decimals and they never check with me. And then on the test they're confused. So if you're not sure how I got those decimals, just ask me right now. Like put up your hand, I can come and show you. it's easy, but before you know it, it's hard, right? It's one of those things. You might just need someone to show you really quick. Okay, so in this question, sine f. Now when I'm doing f, right, I'm hoping people did it, but okay, if I do f, now the only thing that's going to change is that a and o are going to switch spots, right? Like instead of 12 being a and 5 being o, now it's o is 12 and a is 5. So we just swapped them about, okay? Now, so when I do this, sine is still, the hypotenuse doesn't change, right? That never changes. The hypotenuse is always across from the 90-degree angle. So when I do this now, sine of f is O over h. So that's 12 over 13. And we already know what that equals. We don't even need to use our calculator. It's 0.92. Because it's the same as what cosine d was. And same thing with cosine f is 5 over 13. So it's 0.38. Okay, so that's kind of, I don't know if it's interesting, maybe it is, but it just always works this way, where if you're looking at the two angles in a triangle, like the two non-90-degree angles in a right angle triangle, the cosine and sine is always just going to swap. Okay, so like the cosine of one angle will be the sine of the other angle, sine of one angle will be the cosine of the other angle, so it always works this way, just because of the way that the opposite and the adjacent just switch spots if you change what angle you're looking at. Okay, so it's fairly straightforward. So you're going to see that those things match up. If you were finding like if you had to find all sine, cosine, tan for all of the triangle, you'd always notice this. Okay, so it's pretty straightforward. Does anyone have any questions about that? So remember, that's just the ratio. We haven't found an angle yet. That's what we're going to do now. Okay, so here's a situation. I've got my triangle, and I'm being asked to find angle G and angle H. Okay, so if I just pick one, doesn't matter which one you pick. Okay, they're equally good. So if I just do the first one that it said, if I do angle G, I'll move this over a little bit though first. Okay, if I do angle G, okay, I just pick whichever angle I want to focus on. Okay, so that one is up to you. You could do H just as easily. Okay, now once I pick that angle, what I do, and this is where students tend to get a little bit confused and they're not sure how to manage it, is I just label the sides that I'm actually given. If I'm given all three sides, then I can actually just pick whatever I want to do, because I could use sine, cosine, or tangent if I have all three sides. But when I have two sides, I'm just going to look at those two sides. So here I have 6 and 14. So 6 is, yeah, okay, that's great. Some of us are jumping right to it, which I love. But 6 is adjacent, and 14 is hypotenuse. And so the way, some of you obviously have figured out how you're going to do this, but some people might not really be sure. If we have, oops, look at that, that's fun. If we have, oh yeah, sure.
How many have?
This is the only big one, but that's okay. I don't need.
Okay.
Oh, do you just want kids to be able to measure?
Yeah.
Yeah, there you go. And there's one there too. Okay, so what we do is we use SOHCAHTOA. So every time I start, I think about that expression. I actually straight up, I write it down every time, to be honest with you. If I'm doing a lot of trig, I'm going to write that down. And I look at it, I'm like, okay, well, I have A and H. This is the thought process that I want you guys to use. I have A and I have H. And I look at SOHCAHTOA and I pick out the one that has A and H. Okay, so it's ka. So that means that's the one I'm going to use. Just like some people were saying right off the bat, they knew it. It's going to be cosine, because cosine's the one that has A and H. And if taking it a little bit slow, nothing wrong with that. So if I go cosine G, and I know it's going to be A over H, sometimes it's nice to write that down. Okay, so A is what number? 6, and H then is 14. Now, how do you think I would go from that, and that, I mean, I could turn into 3 over 7 if I wanted to. How do we think I would go from this to figuring out what angle G is? Second cosine. So up to now, we've only used second tan. But this is exactly like that, okay? Just like if we had tan equals, we would use second tan. Here, I use second cosine. So I'm going to type into my calculator second cosine, which gives me that cosine -1 of 6 over 14, or 3 over 7, or if you wanted to get the decimal, you could get the decimal. It would all be the same. So I go second cosine, 6 over 14, and I get 64.6 degrees. And that's G, 64.6. We did it. Pretty easy. Okay? It's the exact same as tan. That's the point I want to make, that this is like the exact same as tan. It's just instead of using opposite and adjacent, we used adjacent and hypotenuse. And instead of second tan, we press second cosine. But it's the exact same steps. Okay? So it's nothing really new, just a new button to press, the one next to it. Okay? It's right next door. Okay? So to find angle H, what would I do? Same thing. I could do the exact same thing. I could start like the whole process over again.
Or you can just add 64.6 plus 90.
Yeah. Or I could subtract the 64.6 and the 90 from 180. So it's up to you which you find is easier. I find most students subtract from 180. Like that seems easier. I mean, it does seem easier, right? There's no trigonometry in it. It's just adding and subtracting. Which is easier. Or you can always like completely restart and say, okay, well if I'm looking at H, this side is the opposite instead of the adjacent, and then do sine. Okay, you could set it up as sine. Okay, it shouldn't be the same number, right? So if we're looking for angle H is 180 minus 90 minus 64.6. So if I type that in, 180 minus 90 minus 64, or if you want to, some people add them together first and then subtract, that's totally fine. You get 25.4. Now it's kind of interesting actually, right? Because if you did do it with trigonometry, I just want to point out, like if I did it with trigonometry and I got sine of H equals 6 over 14, and then instead of second cosine, I would type second sine of 6 over 14. It gives me 25.4, or very close to 25.4, same thing. Okay, so it's interesting, right? Like you need to be clear that if I press a different button, like if I press second sine instead of second cosine, it's going to give me a different answer. So you can't just be guessing which ratio you're using. Like you can't be like, well, I think this time I'm going to use cosine. It's not going to work. You need to be aware of what you're picking, because your calculator, it knows you're picking the adjacent and the hypotenuse, or you're picking the opposite and the hypotenuse, and it's doing that work for you where it's telling you the angle. So if you tell it the wrong thing, it will give you the wrong answer. Unfortunately, it's not quite that simple. Okay, so you need to make sure you're always picking the correct ratio. So let's just do one here. I want to make sure, I'm going to give everybody some time. There's no second guessing. You don't have to worry about whether or not you picked the right sides or found the right angle or whatever.